Yes, welcome again on the radioactivity and nuclear reaction. I still remain Mr. Jude. Yes, my name. Yeah, I'm here to let you know that physics, being a subject, is as easy as whatsoever you can think. Very easy. We are talking about binding energy. In our last class, we talked on nuclear fission and nuclear what? Fusion. And I let you know that there is a difference in mass of the original substance before the fission or the fusion, and the what the mass of the what products in the what in the according to what atomic what mass what unit. So today the binding energy, the difference in mass that happens in nuclear reaction is a measure. The difference in mass that happens in nuclear reaction is a measure of the binding energy of the particular nucleus or what nuclear. So the difference in mass, you can look for the video of the where I explain the nuclear fission and nuclear fusion. So that difference in mass that happens in nuclear what reaction is a measure of the binding energy of the particular nucleus or what nuclear. So the this binding energy now is the quantity of energy that must be put into a nucleus in order to break it into its constituent particles. If that is strange to you, remember heat energy changing from one state to another. The energy you need to put into what solids to make it change to what liquids. Just apply that kind of thinking. You get me? So binding energy is that quantity of energy that must be put into a what? A nucleus in order to break it. In order to break it into its what? Constituent what? Particles. Therefore, binding energy of a nucleus is proportional to the difference between a what? The total mass of the individual nucleus and the mass of the nucleus. So we have what? Okay, the total mass of the stable nucleus or nuclei is less than the sum of the masses of what constituents. Okay, for example, in fusion and fission, we we discussed about this. Yes, yes, giving what million energy. What can you see here? What do you observe here? Discover that this original, the mass of this is greater than the mass of this. Even in nuclear fusion, the mass of the infusion, the mass of the what, the large body that split into two, that mass is greater than the sum of the masses of the products add together. So, so how do we now get the energy? So if you can get the difference in that mass, multiply it by the square of the speed of light. This will give you what? Binding energy. But for those who say this is so hard, I cannot memorize this formula, no problem. You can say milk. To get energy, milk multiplied by what? Chocolate multiplied by what? Coffee. MCC. That's C times C giving you what? C squared. So this is the last part of last thing we're going to do on nuclear or radioactivity. So my next video on this, it will be on what? The next video on this will be on what? Soft questions. Questions under all we have done before moving towards the next topic. If no one suggests any topic for us to go into, I will get a topic myself. See you till then. One love.